Okay, so Dom, so about the model 2 balancing of rotating masses. So we'll discuss about the problem on case 3, that is balancing of several masses in single plane. So the second example, a shaft carries 4 masses m1, m2, m3, m4 attached to it. They all are revolving in the same plane. The magnitude of the masses are 6, 5, 9 and 7.5 kg. The CG of the masses are located at radial distance of 100, 125, 150 and 75 mm from the axis of the shaft. The angular positions are 60 degrees, 135 degrees and 270 degrees from mass m1. Determine the position and magnitude of the mass m5 at 250 mm radius to balance the system. So this is the question. So this shows that it's several masses in single plane, same plane. So let's first write down the masses m1, m2, m3, m4. As you can see, m1 is 6, m2 5, m3 9, m4 7.5 kg, r1 0.1 that is in meters, converting 100 mm into meters, r2 0.125, r3 0.15, r4 0.075. So multiplying these two to get the centrifugal force m1 r1, m1 into r1, that is 0.6, m2 r2 0.625, m3 r3 1.35, m4 r4 0.5625. Now resolving these forces horizontally and vertically. So resolving horizontally, we have m1 r1 cos 0 plus m2 r2 cos alpha plus m3 r3 cos beta plus m4 r4 cos gamma. So substituting m1 r1 0.6 from the table, cos 0 0.60625, cos 60 1.35, cos 135, 0.5625, cos 270. Simplifying, we had cos 0 is 1, so 0.6 plus simplifying we get 0.3125 plus minus 0.9545 plus 0. So simplifying all this, we get minus 0.042 as the horizontal force. Vertical force is m1 r1, formula is m1 r1 sin 0, m2 r2 sin alpha, m3 r3 sin beta, m4 r4 sin gamma. So 0.6 sin 0, 0.625 sin 60, 1.35 sin 135, 0.5625 sin 270. So simplifying this, we get 0.3992 as the vertical force. Now to find the resultant unbalanced force, squaring and adding. So f square plus f square square root. So we get, simplifying, we get 0.93414. So for perfect balancing, the fifth mass should be equal to the unbalanced resultant force. So that's why m5 r5 equals to square 0.93414. It's resultant unbalance. So if r5 is already known, that is 0.25. So therefore m5 comes to 3.736 kg to balance the system. Now the position of the this balance system should be placed at the angle. So position of unbalanced force, theta is tan inverse of fp by fh. So substituting, we get minus 87.53 degrees. So this is the balance position of the unbalanced force. So opposite to that, we should keep the m5 mass. Now this was through the analytical way. Now solving graphical way. So for that, first we should draw the space diagram. So as we know, m1 is at horizontal 0 degrees, m2 is at 60 degrees, m3 is at 135 degrees, m4 is at 270 degrees from m1 as a reference. And now to solve this graphically, we should draw a table of mass, radius and force, same as earlier. So name all the masses m1, m2, m3, m4. Name all the radius r1, r2, r3, r4. Multiply them to get the force. centrifugal force M into R. So M1 R1 we get 0.6, M2 R2 0.625, M3 R3 is 1.35, M4 R4 0.5625. So now we will draw graphically. So using this table and this space diagram, so we'll draw this force. We have to draw this force polygon. How to draw this? So first, based on these values, select a scale. For example, 0.6 we cannot draw 0.6 centimeter, it's too small. So we'll multiply this into 10 times, so it becomes 6 centimeter drawable. So the scale is 10:1, multiplying into 10. So 0.6 into 10 becomes 6 centimeter. Draw O to A 6 centimeter line from O to A, and horizontal. Why? Because mass M1 is at horizontal position. So horizontal position, draw 0.6 or 6 centimeters by scale from O to A. Now from point A with respect to horizontal, measure 60 degrees. Measure 60 degrees because mass 2 is at 60 degrees. So measure 60 degrees and draw a line equals 0.625 into 10, that is 6.25 centimeters. So draw a line with 60 degrees, 6.25 centimeters till B. Now from point B, again draw a horizontal line. With that horizontal, now place the third mass, that's M3 mass, at 135 degrees. So take an angle of 135 degrees from this point with the horizontal, and draw a line equal to 1.35 into 10, that is 13.5 centimeter. Draw a line 13.5 centimeter from point B to point C. Now mass 4, this fourth mass is at 270 degrees. So from the horizontal position, 270 means exactly again here 270 degrees. Draw a line equal to mass 4, that's 0.5625 into 10, that is 5.62 centimeter downwards from here to here, C to D. So this stops here. So this is this polygon is incomplete. It means that there is an unbalance. So to balance that, just connect the last D point to O point, initial O point, with a dotted line. And this is the unknown mass M5 0.25. Now measure this angle with respect to horizontal. So this is theta 5. So this is the theta 5, which is unknown. And measure this scale with the scale D to O. Measure with the scale D to O. So D to O into scale is 0.25 M5. So D to O is 9.4 centimeter measured. Scale should be reversed now. 10:1 becomes 1 by 10 equals to 0.25 M5. Therefore M5 equals to 3.76 kg. And the angle is 273 degrees with respect to M1 in counterclockwise direction.